new video today.
All right, we are in Algebra 2. That was good. Today's Friday, March 15th, 2019. Don't know what's going on with my 5 there. There we go. So today we're talking about discontinuities of rational functions. Today is a very heavily, I guess, AP calculus lesson, or just normal calculus, I guess, too. But if you showed this lesson to my AP calculus students, Geo, they would say, wow, that is exactly what we did in Unit 1. Thank you. All right, so let's talk about the hunt for zeros. Graphically, and I guess algebraically, we can have 3 different options when I'm talking about zeros. You can have a normal zero. You can have a vertical asymptote or a removable discontinuity. I will show you what these look like graphically right now. So a zero is something that looks like this. Yoink. See, it touched the 0 height. Yep, draw that. This has a height of 0. H-E-I-G-H-T, height of 0, right there. That's an easy 0. We've seen that before. It's just an x-intercept, basically, right? Pretty easy. All right, a vertical asymptote. We've seen them before. Here is, I'm going to do 2 asymptotes in the same function. So we can have a vertical asymptote that looks like this. Shwink and shoo. So our vertical asymptote is right here. I'll do it in yellow. And I'll move this. It happens right there. Again, an asymptote means you get closer and closer and closer to this yellow line without actually touching it. And it goes on forever, upwards towards infinity. That could be one type of vertical asymptote. You can have another type. Let's go ahead and make another asymptote. Let's say I have another asymptote over here. So I'm going to say this function goes, comes down here, and then comes back up, and gets closer and closer and closer to that asymptote. But instead of coming back down on the other side like that, it's going to magically come on the other side. I can draw that slightly better. It can flip sides. So you can have, those are both vertical asymptotes. Those are both of the types. I guess the other type would be going like this and like this, but so far so good. I mean, if you just graph the basic function 1 over x, let's go ahead and just see what that looks like. Desmos.com / nope, not scientific. I want calculator. If I were to just go to my calculator and graph what is y equals 1 divided by x, that has a vertical asymptote where it does switch sides. We have seen these functions before. And finally, a removable discontinuity. You haven't really seen these before, so I'm showing you them now. You see them all the time in AP Calc. So say I have a function that's coming up here, and then that's not okay, and then it keeps on going on, and I'm going to say, oh, that one's not okay, and then I keep on going on. It's basically, I have a point, but I remove that point. I'm missing a point right there. So we do like an empty circle or an empty dot to say, hey, there's no point right there. So there are 2 removable discontinuities here. Sometimes you'll only have 1, sometimes you'll have none. I mean, you could theoretically have like 100. You could have 1,000 of these if you wanted to. It just means it's a giant function. All right, so far so good. You're following me, Fist of 5. How are you following me? Chris is awake and at a 5. Teflon's at a 4. Geo's at a 5. James, where are you at? You're at a 5? All right. So here is my little shortcut for determining whether you are in one of these 3 categories. If you have a 0 on the top, so I'm going to say 0, and nothing on the bottom, so I'm just going to do a little scribbling. Nothing on the bottom, no zeros on the bottom, that's a 0. Bang. Vertical asymptote, that's where you have a 0 on the bottom and nothing on the top, or I guess something that doesn't match that 0. I'm not being very technical in saying this, but it's going to help us learn the pattern. And of course, a removable discontinuity, what would you guys guess?
Oh yeah, 0.
Scribble, scribble. That would be like 2/3. Not really.
0.
0 over 0. Yep. 0 over 0. We're not doing cards because we have such a small class, but if I come back over here, so James, he made an attempt. James got some XP, Chris,
Do I have my streak on?
That'd
And
be
you-
for
and
you know my
Gio.
streak alive?
Yep, we can do streaks after we finish the notes. All right, so let's do an example. An example of where you would have a 0 is you'd have something like x plus 3 over 5. That would be an example of having a 0. You'd have a 0 at the x coordinate, what?
What?
X equals what to get a height of 0?
0.
No.
2.
No. What makes the top 0?
0.
No. If I put 0, it's 0 plus 3 is 3. How do I make the top 0?
Negative 3.
There it is. Minus 3. If you have x equals to negative 3, that is the 0 of this rational expression. What about an asymptote? I could have an asymptote like this. I could have something like x squared plus 1 over 9 minus x. The top here can never be 0. Try plugging in a number. 2 squared is 4 plus 1 is 5. I can never have the top be 0 unless you have complex numbers. What about negative 1? Would negative 1 make the top 0? Nope. Nothing makes the top 0, so that's an okay. That's my scribble. What about the bottom? What would make the bottom 0?
Positive 9.
Positive 9, yeah. So I have a vertical asymptote here at x equals positive 9. All right, and this one is very special. It has to be the same 0. So I'll make a note here. It has to be the same 0. Same on the top and the bottom. So an example would be something like x plus 7, x plus 7. And then maybe I can multiply the top by, I don't know, something random. But I have an x plus 7 on the top, an x plus 7 on the bottom. Normally what that would mean for us when we're factoring is you'd say, oh, just cancel them out. Well, canceling them out is the same thing as removing that value, as in a removable discontinuity. You're allowed to do that. It just means that I have a removable discontinuity at what x coordinate? At x equals, or negative 7. Yeah, that's where I get my 0. Perfect. Let's go to an example. We only have 2 examples a day and then we're done. These examples are hard though. We have 2 homework assignments. Example 1 is the first homework assignment. Example 2 on the back is the second homework assignment. All right, so our first example. We need to find the zeros, vertical asymptotes, and removable discontinuity. Sometimes you won't have some of these. Sometimes you won't have zeros. Sometimes you won't have these vertical asymptotes or no removable discontinuities. The first step here is to factor. Who wants to factor this for us? Factor, 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 and you get... Do Ninja Star on the top in your head. X...
6.
Careful.
3 minus
3, yeah. X plus 3 and x minus 2. Good. And then on the bottom we have what?
1 and 3.
Careful.
1 and negative 3. Negative 1 and 3.
Negative 1 and 3. There it is. So x minus 1 and x plus 3. Yeah, you guys are getting really good at doing ninja stars in your head for those simple trinomials. All right, and that's all we need to do. We can now talk about the zeros. So at x equals negative 3, is that I'm going to check either this box, I'm going to check either this box or this box. I have to choose one of them. Which of these boxes do I check?
0.
So it's on the top, right? So that's why you're saying 0. We see a 0 on the top. So you're thinking like that?
No, it's removable. This whatever.
Why is it a removable discontinuity?
Because there's 2 zeros on the top and the bottom corner, and it's the same 0.
Ah, it's the same 0 on the top and the bottom. So you're correct, Gio. You got it. All right. Let's give it to someone new. X equals 1. What is that?
0.
That's a 0 right here, Chris?
Yes.
Okay, why? Go
No,
back.
It's not, wait, this is
It's a 0 because the 0's on the top.
Yes.
So when I plug in 1, which of these things, which of these 4 linear pairs goes to 0? The bottom. When I have a 0 on the bottom, that's a asymptote. All right, so it is a vertical asymptote. All right, let's do that kindergarten thing where you all say the same word at the same time. So it's going to be vertical asymptote. Asymptote. It's as if the P is silent. Asymptote.
Asymptote. Asymptote.
Keep trying. Asymptote.
Oh, tote.
Tote, like a tote bag. Asymptote.
You don't say the M?
The P is silent. So asymptote.
Asymptote.
Yeah.
Asymptotes.
Asymptote. The reason I'm making you do that is because if you ever ask Sophia to pronounce vertical asymptote, she'll say vertical asymptote. She still can't pronounce it. Now you guys are
So you know
one
what
up
that
on
means?
Sophia.
X equals 2, it has to be 0.
All right. It doesn't have to be 0. It could be double vertical asymptote, but let's check it out. So let's give it to Teflon or James.
So this is in the top.
Teflon or James?
It's 0 past that.
Chris. All right. Teflon or James? At x equals 2, which of these 4 terms is 0, and why is that one of these 3? Yep, we have x equals 2. So top left, top right, top, bottom left, top right. This one goes to 0, and therefore it is a 0. Yep, because we have a 0 in the top. It's that easy. So the hardest part is to factor and then remember what these tables are. Try to remember, if I had to remember any of these 3 things, remember this row here. That's the row that you need to memorize.
Oh my god.
Memorize this row. I'm going to write that as a note. Memorize this row. All right. And then we're on to the back.
Do you realize that when you make a star, only one angle comes out round?
Only one angle comes out round? What do you mean?
Do you know that?
What angle comes out round?
Do it fast. Yeah, you see that?
Which?
It comes out round.
This one right here?
Yeah.
It's weird. Maybe I just need to work on my stars. All right, so this is the second part of your homework. It's going to ask you this question over and over again. It's the same question over and over again.
Well, I've looked at a lot of reading, right?
Let's analyze what this is even saying. We have this function here. Obviously, it does have a 0. It has a 0 at what x value? A 0 is where the top is set equal to 0. So it has a 0 at...
The bottom.
All right, hold on. 0. So when I say 0, I'm in this column. I know that 0 is like referring to many things, but when it's actually at a 0, that means the numerator, the top, is set equal to 0. If I set the top equal to 0, that has an x value of... Uh-oh. That was just a review question. I wasn't... So x squared minus 1 set equal to 0. Add 1 on both sides. X squared equal to 1. So therefore x is equal to...
Positive, negative.
Plus or minus 1, exactly. All right, so we have 2 zeros at positive and negative 1. But coming back here, I want to know the vertical asymptote. I need to know if I am going from the negative or the positive side. So it's very similar to asking this question. Are they both going to positive infinity? Is one going to positive infinity, one going to negative infinity? Or maybe both of them coming to negative infinity? That's the question that I'm asking you over and over here. I'm asking you about this graph. What's happening? And here's what you do. In order to determine if you're approaching from positive infinity or negative infinity at the vertical asymptote, by the way, positive infinity would look like this or like this. Negative infinity would look like this or like this. Go ahead and write those arrows. That's what positive infinity looks like. That's what negative infinity looks like. At the vertical asymptote, all you need to do is plug in. A more formal word would be substitute. Plug in values close to the asymptote on either side. I'll show you what that means on example 2. And I think we have example 3 as well, right? Yeah. Oh, whoops. I forgot to change that. Mr. Sindel. Change that to example 3. All right. This is what happens when you make everything from scratch. So, in example 2, what is the x-coordinate of the vertical asymptote? It tells you in the problem. But you can also tell just by looking at this function. What just happened there?
Bottom.
What is the Yes, it's the bottom. So set the bottom equals 0. You get x equals
3.
3. And it tells you also x equals 3 right here.
Oh, so you just
No, good. You're doing good. So I need to figure out what's happening at 3. I have one of 4 possibilities. I'm going to do a quick sketch of what A is saying. A is saying it approaches negative infinity from the left and the right. So A is saying it has a graph that goes like this.
No.
B is saying as I go from the left, I go to negative infinity. So from the left, negative infinity. Right, positive infinity, like this.
D.
C is saying the opposite of this, so it goes positive infinity from the left and then negative infinity from the right. And then D is saying positive infinity for both of them. So this is a sketch of D.
I think it's C.
I think it's B.
All right, what we have to do is we have to plug in a value close to 3. What are our 2 values going to be?
2. 1.
Let's choose even closer, just in case we have multiple things.
2.5, yeah.
I'm going to choose
2.75.
2.9 and 3.1.
1.
Those are my 2 values, and I need to check if it's positive or negative. If it's positive, that means it goes to positive infinity. If it's negative, it goes to negative infinity. So I'm going to plug in those values and see what happens. At 2.9, what's the top? When I plug in 2.9, the top is going to be 2.9 squared, which is a big number. It's over 4, because 2 squared would be 4.
5 point.
But it's positive, right? So we have a positive on the top. When I plug in 2.9 on the bottom, I get
Negative.
negative. So overall, you get a
Positive.
yikes.
0.
Negative.
Positive divided by a negative
Negative.
is a negative.
I 0.
So 2.9, was that on the left or the right?
Left.
That was left. So the left should be negative infinity. From this yellow, it has to be negative, so it can be this option, but it cannot be these 2 options because those are both going to positive infinity on the left.
I think it's B.
It's B.
All right, let's see.
No,
Now I'm going to do this in black. So when I plug in 3.1 on the top, I get positive or negative?
Positive.
Positive. When I plug in 3.1 on the bottom, I get a
Positive.
3.1 minus 3. Is that positive or negative?
Positive.
It's positive. Positive divided by a positive is a...
Negative.
Yikes. You guys. I mean, you're participating, which is awesome, but a positive divided by a positive is a positive, which means on the right-hand side, I should be going up. So it's not A, it is B.
See, I told you.
You guys did tell me. Let's see if you guys can do example, and I know it says 2 in your notes, but let's see if you can do example 3
On your own?
on your own. It's going to be the same options. These sketches are repeated over and over again.
Oh, I did it on the wrong
All right, go ahead and do example 3 now. All right, so we've had a bit of time. Raise number of fingers. A is 1, B is 2, C is 3, D is 4 fingers. Gio is saying C. Chris is saying B. James and Teflon.
I could be totally wrong.
Teflon doesn't know. James is saying A.
I'm saying B because they're on the wrong one.
Oh, gosh. All right, so what number did you choose to plug in? This should be a negative 3, by the way.
Oh, what?
So you see, it is B.
That is a teacher mistake.
I found that.
Because if I'm looking for the vertical asymptote, I'm setting this bottom equal to 0. That happens at x equals
Negative 3.
negative 3. So my values to the left, what should my value on the left be?
Negative 2.9 and 3.1.
Oh, be careful. On the left is going to be,
3.
what's less than negative 3?
2.9.
Negative 2.9.
That's on the right. Negative 2.9 is on the right.
Dude, you just said.
If I'm looking at a number line,
4.
0, negative 1, negative 2, negative 3. What is to the
4.9.
right?
4.9.
Negative 3.1.
Negative 3.1 is on the left. Negative 2.9 is on the right. So negative
I just said
3.1.
that.
You did say that. You both said negative 3.1. I did not ignore you, Chris. I heard you. And I'm not writing it down because Gio told me that's the number I'm going to choose. All right. So what I'm going to do now is I'm going to plug each of these in to see what happens to my function. And I'm just going to guesstimate here. So if I plug in negative 3.1 and I square that, I get roughly some number slightly bigger than 9.
Wow.
A positive 9. And then I'm going to subtract about 6. And then I'm going to subtract another 2. So I still get a positive on the top. On the bottom, do I get a positive or a negative?
Negative.
We do indeed get a negative. So
Yeah.
James, a positive divided by a negative is a
Negative.
Negative. All right. That means on the left side, I should be going to negative infinity.
So I see. I told you.
So it's not C and it's not D.
It's B.
Whoa, it's A.
B.
All right. Now we're going to do this one. When I plug in negative 2.9, on the top, I get what?
A.
You don't get A. When I plug in negative 2.9, now I get something slightly smaller than 9.
8,
9 and then minus...
3, 2, plus 2.
Wait a sec.
Dude, it's
You did it wrong.
I did do it wrong.
Oh my god.
God.
Because I messed up on the top. On the top. If I plug in negative 3.1, I should get... Oh, no, I did it right. I don't know what I'm saying. I doubted myself. I shouldn't have doubted myself.
It's not A.
So, when I do this...
It's B, man, I'm telling you.
I'm starting to doubt myself again. Okay, hold on.
Yo, I'm gonna
If
get
I
a
plug
t-shirt.
this in, I should get 9, roughly 9. Then I subtract roughly 9. So if I this is basically, when I plug in negative 3.1, these two values are almost dead even. So what's dead even? It's basically 0. 0 minus 2 should be...
2. 0.
Oh, God.
Wait, what did you say?
What's 0 minus 2?
0.
0 minus 2.
Negative 2.
Negative 2. Is negative 2 a positive or a negative?
Negative.
Negative. And on the bottom we already discussed we had a negative. Negative divided by a negative is a positive, which eliminates A and B.
Dang it. Wait.
Oh, so it's C. I told you.
It could still be C.
No, what? You said it was neither C or D.
I thought so, but we messed up on the top. The numerator messed up.
Oh, so it wasn't A. Whoa.
All right, let's try the next one. When I plug in negative 2.9, on the top I should get a negative.
Wait, it's not B though?
On the bottom I should now get a positive.
Oh, it's D. It's D. Wait, no. No, never mind.
Whoa.
The answer was C.
Oh my gosh.
This was the right. The right is negative. The right is negative. The left was positive. The left was positive.
Told you.
Can you play game?
All right, and that concludes example 3.